This diagram depicts a Blue Yonder WMS library test case called Terminal Inventory Audit Count. It represents an automated test for when a user in the warehouse is prompted on their RF gun to verify the inventory quantity at a specific location. If you would like to follow along locally, go ahead and pause and open Base Count 40 in your library. This top gray section represents the test case itself. The test case will proceed from steps 1 all the way through step 7. As you know, a feature file can be structured into a background, which executes before any scenarios within the feature file, a scenario outline, which executes once for each row of data it is fed, and an after scenario, which executes after any scenarios within the feature file. In step 1 in the background, the framework will perform setup, including loading the environment, dependencies, configuration data, as well as triggering any custom functionality. In step 2 in the background, the library will load test data into the system under test that the test case will use. In steps 3 through 5 in the scenario outline, the library will log into the terminal interface, perform an audit count, and verify the results. In step 6 in the after scenario, the library will log out of the terminal. In step 7 in the after scenario, the library will clean up residual test data so that the test can be executed again and again and again to prevent regressions. All test cases are driven by test case inputs. In the library, these test case inputs are in a CSV file called basecount40.csv. Each row in this CSV file represents an independent execution of the test case with differing data permutations, also known as examples. The first example in the CSV could represent a perfect audit count. The second example could represent an overage. There is more inventory than expected. The third example could represent a shortage. There is less inventory than expected. If your test case and the underlying utilities are designed well, it should be able to support a variety of data permutations. Every test case within the library is composed of building blocks called utilities. These utilities are designed to be reusable and extensible. Below the test case, you can see the various utilities that compose this test case. Each number next to each utility corresponds to where it is used in the test case above. You can see some portions of the test case, such as the audit count, are composed of many utilities. Other portions, such as the terminal login, are composed of single utilities. In order to easily mix and match utilities to create your own test case, utilities are organized into functional areas. Think about a room with building blocks where certain colors of building blocks are in a specific bin. Similarly, terminal counting utilities are placed in the terminal counting utilities feature file. When needed, you can customize a default utility and replace it with ease, allowing you to swap in and out specific utilities while still being able to rely on the default utilities. For example, your site may have a unique workflow to call a supervisor in the event of a shortage for an expensive inventory item. This would require you to modify the audit count complete count utility to account for that workflow. This functionality is what we refer to as layers. You can generate layers for specific sets of functionality that are associated to a given template or site. Let's take a moment and map this diagram to the actual test case. Keep in mind that every test case within the library is structured exactly the same for simplicity and transferability of knowledge. Lines 1 through 56 represent the feature header. The feature header contains metadata about the test case, such as a description about what the test case does, the required test case inputs and descriptions, and overall assumptions. Lines 64 through 72 represent the setup in the background. Lines 74 through 87 represent the data load in the background. Lines 104 through 125 represent the test case itself. We can see the terminal login utility on line 112 and the audit count utilities from lines 115 through 118. Lines 94 through 95 represent the terminal logout. Lines 97 through 102 represents the data cleanup in the after scenario. We can also navigate to the test case inputs. We can see on line 106 that there is a reference to the path to the inputs. While this new installation of the library has it in the samples folder, we can find the corresponding base count 40 and open it to take a look inside. We can see several different examples in this CSV. Finally, if we wanted to hunt down one of the relevant utilities, we could navigate to the Utilities, Base, Terminal Counting Utilities feature file. We could hit Control F and search for Terminal Inventory Audit Count Perform Count. We can see at the top of this feature file there is also a feature header with slightly variant metadata that contains a listing of all of the utility scenarios within this feature file. We can also see that all utility scenarios have what we call a scenario header. This contains metadata about what the utility does, what scripts it executes, what inputs it requires, or it can be optionally provided, as well as what outputs it generates. This utility is divided into blocks of activities. Each unindented step represents an activity within the utility, and the indented steps following it represents the functional steps performing that activity. This utility verifies we're on the count adjustment screen and enters a load number, sees the cursor at the part number field, sees the cursor at the client field, enters the quantity, sees the cursor at the quantity field, enters the pallet quantity, enters the case quantity, and then enters the actual amount we want to count in eaches. When you need to customize a utility, you can quickly identify where within the existing activity steps a change needs to be made. For example, in our supervisor example from earlier, we may want to add additional activities subsequent to entering a shortage quantity on line 743. Now it handles a shortage by having a supervisor enter their approval password. Hopefully, this walkthrough has provided a thorough understanding of the structure of a test case.